Welcome to myprojectbazaar.com. Let me see the project CCBKE Session key negotiation for fast and secure scheduling of scientific application in cloud computing. Instead of purchasing and maintaining the own computing infrastructure, scientists can now run data-intensive scientific application in hybrid environments such as cloud computing by facilitating its vast storage and computing capabilities. During the scheduling of such scientific application for execution, various computation data flow will happen between the controller and computing server instances. Among various quality of service metrics, data security is always one of the greatest concern to scientific, because their data may be intercepted or stolen by malicious parties during those data flow, especially for less secure hybrid cloud system. An existing typical method for addressing the issues is to apply the internet key exchange scheme to generate an exchange session key, then to apply this key for performing symmetric key encryption, which will encrypt those data flow. However, the internet key exchange scheme suffers from low efficiency due to its asymmetric cryptological operation over a large amount of data and high density operation, which are exactly the characteristic of scientist applications. In this paper, we propose cloud computing background key exchange, a novel authenticate exchange scheme that aim at efficient security aware scheduling of scientific applications. Our scheme is designed based on randomness, reuse strategy and internet key exchange scheme. Theoretical analysis and experiment result demonstrate that compared with IKE scheme, our CCBKE scheme can significantly improve the efficiency by dramatically reducing time consumption and computational load without sacrificing the level of security. Let me see the flow diagram. First, Hadoop will run under the Ubuntu platform. There are various instances of Hadoop for job execution. Various nodes are running for the Hadoop. First job in user side, when a user is uploading a file, then the file have to be securely transformed and stored in the cloud environment. First, a Diffie-Hellman approach is applied to generate the keys, and a random prime number is generated. Diffie-Hellman is used in SSL certificate generation. Here we used the same mechanism. Then secure key. After security constraint and defined checking, both side client and server is verified. Then both key are same. Then a job is submitted. After job submitted, the file has to be splitted, and the splitted file is encrypted with symmetric algorithm like AES algorithm. After that, each file is stored in separate nodes. Now, Hadoop is used for storing big large amount of files at less time. Then separate key is generated for the stored file. While getting the file, we have to use the key to retrieve the files from the Hadoop environment. Let me see running demo for CCBKE. First, choose a file format. The file can be any one of these file format. First, choose the file. First, I choose the file. Then extract the contents. These are the original file. Now process. Here a Diffie-Hellman group is generated, prime number, then group generation. After that, public value. Now send the value here. After that, start the server. CCBKE server and on Hadoop server. Now receive the value, generate public value here, generate secret key, then send it to client. Now client receive the value, generate secret key, generate signature. Here also generate signature, verify, the both key are true, then load a file into HDFS location. Now the file is stored in the Hadoop location, Hadoop environment, in the file name aclogout1. Now click process. This is loaded content, encrypted content. Now proceed, splitter, then view message. This is splitted message and encrypted text of a file. This is original contents. Now click proceed, key and group values. These are key and group values which is generated first. Now load int. These are the job for each nodes. Then click proceed. Now job execution. This is execution time of each job. Then a graph. This is comparison graph of AES and RES algorithm.